Okay, so here's the first row of that transformation handout that you should have printed out or at least have handy. So what we're going to talk about today is called vertical transformation. So vertical up and down, right? We're going to move a graph. So notice this example is y equals x squared. We know that the parent graph should go through 0, 0, right? And look kind of like this. Sorry about my terrible drawing. Right? So that's the parent graph of y. This is just y equals x squared, right? And so the key here is if you add outside, so that plus b, all it does is it moves every point up 2. In this case, 2, right? Or up b, right? So if you think about y equals x squared, here, this is kind of small, but if you look on your chart, right, here are the regular points if it was just y equals x squared. And then all we did is just move every point up 2, right? So this was 1, 1, it moved up, 1, 1 moved up. Not a big deal. Okay, so now what we have is minus b, right? That's what's happening here. Again, here is our parent graph of square root of x. You know what that looks like. In this example, we're just minusing 3, right? So here's what our normal points were, and then we just move everything down 3. So they were up here, and now they've moved down, right? They've all moved down. Notice that while I know you have memorized, or you will have memorized the y-intercepts, for this, as we move further in it, it's going to be really nice to have a couple other points memorized in the parent graph. But we'll work on that in the next few lessons. Okay, so now we have a little bit of a different graph, okay, a different transformation. So if you notice here, what's happening is we're multiplying in front, right? So that means, if you look at the relationship here, so here's our xy if it was just, say, x cubed, and we're going to multiply our y's by 4, right? So what this graph normally look like is, you normally have a y-intercept at 0. 0 times 4 is 0. Our next point is usually at 1, right? So this is normally like this, or here. So it's a little bit flatter, right? And we're multiplying by 4. So it's not that we're moving up 3 here. We're moving from 1 to 4, right? Our next point, if you think about if we were going to extend this chart right here, if we normally had to, right, 2 cubed is 8. 8 times 4, our new point would be 32. So it's going to get, where on this red graph, we'd normally be, if x is 2, we'd be up at 8 somewhere, right? We'd be up at 8. Sorry about my ugly graph. This green graph now, this point at 2, way up at 32. Okay, so we're just multiplying by 4. Okay, our last transformation is this negative, okay? And all that does is flip it over the x-axis. So everything else is gonna stay the same distance from the x-axis. It's not gonna dilate or get skinnier or anything like that. It's just gonna full-on flip, okay? So if you notice what's happening, right? Our x's stay the same. Our y's just go from +3 to -3, +1 to -1, etc. Okay, so now we're just going to do one example just to practice, okay? So when I look at this, I notice I have all 3 transformations. I have an +1, I have a ×2, and I have a flipped, right? We're going to kind of use our order of operations, and we're going to do these. So this comes first, then multiplying, then the adding. Right? So it's always nice to think about your parent graph. So I'm going to draw that here. We know our y-intercept is 0. Just for now, it's nice to know we have also these points, 1, 1, and -1, 1. Right? That helps define our parabola. Okay, so if we flip, what that means is our parabola is now going to be facing down. If we multiply by 2, okay, what that does is that takes these points and moves them up 2. So in blue right now, I'm just going to do a little mini thing. We're going to multiply everything by 2. So that stays 0. We're going to move up to 2 and up to 2. So we got kind of like a skinnier graph. Okay, we've got a skinnier graph. Okay, so that is simply, this blue one is is just 2x squared, right? We're gonna, if we put the negative in front, right, it just flips it over. And now what we're gonna do is add 1. So here's what we'll do. Sorry, let's flip it first, actually. So we're gonna flip this. So, and it's really nice to think about these points. So this point is 1 comma negative 2. And this is negative 1, negative 2. So this is now negative 2x squared. Okay, now we're going to add 1. Okay, and we're going to do this in green just so that it looks different. So what we're going to do is we're going to take this upside down one and we're going to add 1 to every point. Right? So look where we are now. Right? So this moved up to, right, just moved up 1, negative 1, 1, negative 1, 1, sorry, and 0, comma 1. So the green is our final answer, okay? Okay, I want you to try 1 entirely on your own to bring to class whenever we have class next. So why don't we try y equals negative 3x cubed plus 1. Okay, so there's an example kind of like this in the notes. I want you to try it and bring it to class.